Hi, now we are going to discuss about the graphical representation of cos and sec and their domain and range. So this is the positive direction of x-axis, this is negative direction of x-axis, this is positive direction of y-axis, this is negative direction of y-axis. So we are making a scaling of these angles as an interval of pi by 2, this is pi by 2, this is pi, this is 3 pi by 2, this is 2 pi and continue. This is minus pi by 2, this is minus pi, this is minus 3 pi by 2 and this is minus 2 pi and it is continuing. Here are the values of these functions, that is 1, this is 2 and it will continue like this, and here the values are minus 1, that minus 2 and it continues like this. See how cos behaves like. What is the value of cos 0? We know the value of cos 0 is 1. And what is the value of cos 90 degree? It is 0. So it looks like this. And here it will be like this. So let me write that pi by 2 in a better manner, and here also. Okay. This is pi by 2. This is minus pi by 2. Look at carefully. You see that cos 0 we know 1 and cos 90 degree is 0. So between this range 0 to pi by 2 it is actually decreasing, and it is further decreasing till pi. Okay. So between 0 to pi the function cos is decreasing, and what is that maximum value at the point 0 is 1. And what is the minimum value at the point pi is minus 1. And from pi, so what you see is this is the value, this is the pi. And here it is a value minus 1. And here is a, then after pi it starts increasing from minus 1 and it is increasing and attains the maximum value of 1 at the point 2 pi when the angle is 2 pi. So this is the maximum value, which is this one. Assume that this is 1. Okay, so you can make this curve like this. Okay, this is the value 1. Correct. Now again it started decreasing this, and here also you see from 1 it starts decreasing till 0 to minus pi by 2. So from minus pi by 2 to 0 the function cos is increasing. It is increasing from minus pi by 2 to 0. It is increasing. From 0 to pi, it is again decreasing. More specifically to say, it is from 0 in the negative angle, it is decreasing, started decreasing till minus pi. And it is attaining the minimum value of minus 1 at the angle minus pi. So this is the minimum value. And then, after minus pi, it starts increasing. And it's attained the maximum value at minus 2 pi, and in that way it is continuing. Clear? Right. So what is the domain of this function cos? Domain of this function cos is again any number, any real number. You see, any value it can take, but it cannot return any value. That means range could be different. So what we see is that in cos, the domain is the set of real numbers, that is minus infinite to infinite. And what is the range? Let us look very carefully. The value cos can return any value between -1 to +1. You see, whatever the curve I have drawn in red color, it covering the interval -1 to +1, including -1 and +1. That means it is covering the closed interval -1 to +1. But you will never find this curve is going above 1 or below -1. It is never going. See, it is never going above 1, and at the same time it is never going below -1. That means the function cos can return any value between -1 and +1, including these 2 points -1 and +1. So that means its range is -1 to +1 closed interval. Clear? Good. Now let's discuss about the graphical representation, domain and range of the reciprocal of cos, which is sec. Let's see how it looks like. So this is the origin, this is positive direction of x-axis, this is the negative direction of x-axis, this is positive direction of y-axis, this is negative direction of y-axis. Let us measure the angle along x-axis with an interval of pi by 2. This is pi, this is 3 pi by 2, and this is 2 pi, and it continues like this. In the negative angle, this is minus pi by 2, this is minus pi, this is minus 3 pi by 2, this is minus 2 pi, and it continues like this. The values of this angle is actually, here it is 1, here it is 2, and it continues like this. And in the negative side, here it is the value minus 1, here is the value minus 2, and it continues like this. Now, what is sec? As you know, it is a 1 by cos. So that means, if you see, we can flip the curve between the line here, minus pi by 2 to pi by 2, right? So it will be flipped from this one. So we can flip around the point 1 in the upper direction, it will be like this, without touching the point minus pi by 2 and pi by 2. Why it should not touch the point minus pi by 2 and pi by 2, I am going to come. So it looks like that around the point 1, okay, it will be looks like this. Okay, but it cannot touch the point pi by 2. And here also it cannot touch the point minus pi by 2. It will go like this, it will continue like this, and this also, but they will never touch. That's why these lines are known as asymptotes to this curve. Okay. The point is, why it cannot touch the point pi by 2 and minus pi by 2? What is the value of cos pi by 2? Is 0. So what is the reciprocal of this 0? Means 1 by 0, which is the value of sec pi by 2, is not defined, right? So see, as it is not defined, we really cannot find the value of sec pi by 2. Similar manner, we cannot really find the value of sec minus pi by 2, and that is the reason that this curve cannot really touch that point. If it touch, that means we find the intersection between this curve and this straight line, but that is not possible, right? Because sec 90 degree, that is sec pi by 2, and sec minus pi by 2 is not defined. In the similar manner, we can find between pi by 2 to 3 pi by 2, Okay, if we find the value of sec, it will be flipped around the point pi and it will be like this. Sure, let us draw. So here where this is the line which is getting continued, here also it is getting continued, and the curve will be like this. Okay, and it can attain this value -1 here. -1 is this value, and it again in the similar explanation, the curve cannot touch these lines x equal to pi by 2 and x equal to 3 pi by 2. Fine. In the similar manner, we can find the value between minus pi by 2 to minus 3 pi by 2. Okay, what it will be? It will be like this. Alright, okay, and here it attains the maximum value of -1. Correct. So what we see, what is the domain of the function sec? So the domain is any real number except the odd multiply of pi by 2. Why? Here it is pi by 2, it cannot touch. Here it is 3 into pi by 2, it cannot touch. Similarly, we can find 5 into pi by 2, 7 into pi by 2, 9 into pi by 2. In that way it will continue. And in the negative angles, we cannot find, we can find that it cannot touch minus pi by 2, it cannot touch minus 3 pi by 2, it cannot touch minus 5 pi by 2, minus 7 pi by 2, minus 9 pi by 2, in that manner. So we see the domain of the function sec is any angle except the odd multiple of pi by 2. So how we can represent whatever I said in English in the form of a set notation? Here it is. Alright. Any real number except means the difference between sets are minus. So odd multiple of pi by 2. So we can write it there like this. 2n plus 1 into pi by 2, where n is an integer. If n is an integer, 2n plus 1 will always be an odd number, right? Odd integer. So it will be the odd multiple of pi by 2, that is the domain. And what is the range? Range, we see that any value in the real number except the values between -1 to +1. If you look at this curve, what I have drawn in a red color, it covers all the points except this any point between -1 to +1. You cannot find the red curve has been drawn and it is crossing any value between -1 to +1. But beyond 1 and below -1, it is covering all the points. Right? So we can say the range of this function is -infinite to -1, then 1 to infinite. So how we can represent in set notation? Here it is. So the range is -infinite to -1 union 1 to infinite. Clear? Alright. So next we are going to discuss about the graphical representation, domain and range of tan and its reciprocal cot. Meanwhile, I will suggest you to spend couple of minutes, understand very clearly about their graphical representation, domain, range, and we will proceed further with tan and cot. Thank you.